Good afternoon all. In day-to-day life, the electronics is developing. We are showing that the electronics is developed from a small and negligible particle, electron, and then developed from a consumer electronic devices to space electronic devices. So we have to learn about the basics of electronics. It is necessary to learn about the basic electronics of an electronic student. If it is an engineering field or any other graduation field, electronics is included. So we want to give the classes regarding electronic devices and electronic circuit analysis. As my first class, I want to demonstrate about the basics of electronic circuit analysis. So electronic circuit analysis, before going to this subject, we have to discuss about the basic electronics. Once upon a time, the electronics is the integral part of electrical engineering. There is no electronics before, once upon a time. But how it is developed? It is developed from a small and negligible, a small minute particle that is called electron. According to the theory of nucleus that is given by Rutherford, Sommerfeld and some other scientists, given about the electron revolution around the nucleus, in which concept, suppose this is a nucleus of a material, so in which positive charge, that is called proton, in which a negative charge, that is called, it is a low charge particle. Low charge particle. The negative charge particle is revolving around this nucleus. Okay. The electrons are revolved around the nucleus in the shape of orbits. Okay. So this shape of orbits, some of the electrons are revolving according to the material type, we know that. So this is one more orbit. This is also one more orbit. So finally, I am telling about the outermost orbit. So in each and every orbit, electrons are revolving. According to the material, there are the number of electrons according to electron configuration. So here I want to tell about the electronic development. In this theory, we have to observe that how many electrons are revolved around the nucleus in the outermost orbit. In the outermost orbit, only maximum electrons, only 8 members. 8 number of electrons only revolving around the outermost orbit. Okay, maximum 8. It will be 3, it will be 2, it will be 4, it will be 7. Maximum number is 8. Okay. So depending upon the number of electrons revolving in the outermost orbit of your nucleus, all the materials in the universe are broadly classified into 3 categories. Those 3 categories are conductors, semiconductors, insulators. Conductors, semiconductors and insulators. In which basis they are divided? The maximum electrons revolving in the outermost orbit. Okay. Here we can say that the conductors conducting electricity well, insulators not conducting electricity, semiconductors, these are having the properties in between conductors and insulators. Okay. How these are divided according to the maximum number of electrons? Okay. Semiconductors in the outermost orbit, exactly 4 electrons, outermost electrons. Those are called valence electrons because of it is valency shell. Okay. Conductors. It is less than 4 electrons. If the less than 4 electrons are there, then it will be act as a material act as a conductor. Next, greater than 4 electrons, it will be act as insulator. So in these materials, the important properties to the electronics, useful properties to the electronics, having only semiconductors. So the semiconductor materials are taken, and then the semiconductor properties are changed, because the pure semiconductor doesn't conduct electricity. So according to doping process using the other materials, the semiconductor materials are divided as P-type semiconductor and N-type semiconductor. These are the basics just to know. So I am telling briefly about this. P-type materials, N-type materials, semiconductor materials. P-type and N-type materials, because of these properties are completely opposite, quite opposite. In P-type material, the conductivity is by major part, that is having holes. Those are the charge carriers. Holes are the charge carriers. Positive charge is the major part. In which N-type, the negative charge is the major part. So majority charge carriers, P-type material holes, N-type materials electrons. The opposite are minority carriers. Okay. So here the P-type material is positive charge material, N-type material is negative charge material. P-type, N-type, both are opposite charges. Whenever these charges are side by side, then the P-type and N-type are side by side. The P-type material, N-type material are attracted because opposite charges attracts. So in which the P side positive charge, P side positive charge and N side negative charge are attracted. Due to this attraction, there is a barrier between these two materials. There is a junction formed between these two materials. The junction is called PN junction. It has two materials, just like two terminals. The P-type material and N-type material are formed just side by side. There is a formation of PN junction with two terminals. It's a device with two terminals, anode, cathode, you know that. This is the first electronic device. It has the major role in the development of electronics. The device name is PN junction diode. So why it has such importance? Because the major property of this PN junction diode is AC to DC conversion. AC to DC conversion. Whenever the AC is converted into DC, then only the electronics is started. If AC is not converted into DC, there is no electronics. So this is the main device in the development of electronics. Whenever the electronics is started, then only with DC, because AC to DC conversion is started by this device. Using this device, we can connect a circuit. Using this device, we can connect a circuit, we can design a circuit that is called rectifier. AC to DC conversion is nothing but rectifier. So diode is nothing but rectifier. Okay, let's go to the rectifiers concept. Okay. In the previous verse, I am telling that just only the basics, how the PN junction is formed, just basics, in which in the PN junction there are forward biasing, reverse biasing, okay, the biasing conditions, temperature conditions, all are there. My opinion is to tell about how the electronics is developed from its negligible small particle. Okay, that's why. So next, using diode. Diode means two types of materials like this, P type, N type. We are already discussed. It's a device with two terminals, anode, cathode. The technically it is the symbol. Technically it is the symbol of the diode, anode, cathode. It is unilateral device. Unilateral means cathode K. Unilateral means only one directional. What is the meaning? Only one directional means it takes input and delivers output. So already we know that AC to DC conversion. Input side AC is taken and output side DC will be generated. Okay. So here unilateral device means it works with only anode to cathode. It transfer anode to cathode. Anode is always input, cathode is always output. So in this type of connection, here the symbol is this side current flow, the arrow mark, this side current flows, this side not allowed. This side current flows and this side not allowed. So the symbol like this. This side arrow, that side gate, stop. Okay, this symbol is like this, anode, cathode. So this is unidirectional device. Using this circuit, we have to go to design rectifier circuits. Half wave rectifier, full wave rectifier, the bridge rectifier, so many types are there. The half wave rectifier. Okay, rectifier main aim is to convert AC signal to DC signal. So AC signal to DC signal conversion. This is a transformer, step down transformer, in which a 230 volts AC supply is step down to according to the circuit. Suppose for example 12 volts. This 12 volts, this is also AC. This is also AC. Why we are decreasing this 230 volts? This device cannot accept. This device only accepting low voltages. That's why it is taken the input and delivers the output by converting this AC into DC. This is the main aim of rectification. Okay, in which we are using the transformer to step down the mains supply. Okay, here the electronics is developed from the rectifiers, and then the communication side it is developed, that is transistors. Transistor is side by side connection of two diodes. Okay, this is side by side connection of P type and N type. Similarly, two diodes are connected side by side. Then it is a device formed, that is transistor. In this transistor, we can analyze this transistor according to the transistor circuits. The major application is amplifiers. Amplifiers means there are CE amplifiers, CC amplifiers, basic amplifiers. Okay, three terminals are there. According to the three terminals connections, biasing connections, we have to divide three types of amplifiers: common emitter, common collector, and common base amplifiers. These are the general amplification circuits. From this, the amplification is developed up to power amplification. There are so many types of amplifiers using the BJT, bijunctioner. Bijunction means two diodes are connected side by side, back to back connection. So this type anode అంటే P type, this type N type, this is also N type, this is P type. So this layer is totally N type, this is totally P type, this is totally P type. Okay, so here this is one terminal, this is one terminal, this is one, three terminals and two junctions available. This is one PN junction, this is one PN junction, two junction, three terminal device. So according to the connections, we have to use the polarities. Two power supplies needed for two junctions. Okay, so that according to the connections, there are three types of amplifiers available, basic amplifiers. In this amplifier circuit, we have to give the feedback, concept of feedback. The concept of feedback, it is two types: positive feedback and a negative feedback. If an amplifier is positive feedback, the output of the circuit is taken and fed back to the input. The output, the sample of output is connected back to the input, is called feedback. The feedback is two types: positive feedback and negative feedback. Positive feedback is employed in the amplifier, it is called as oscillator circuit. Oscillator circuit. Please remember that this is positive feedback is employed in the amplifier circuit, it is oscillator. But negative feedback is employed in the amplifier, that is called negative feedback amplifier, amplifier action. Okay, this is the concept in the ECA subject, that is electronic circuit analysis, in which the feedback amplifiers is the major chapter. Okay, we have to discuss about that later. So here from the basics, this is the feedback amplifier concept. There are two types of feedback. In amplification, negative feedback is used. In oscillations, the positive feedback is used. Here the concept is, suppose it is an amplifier, the block amplifier. It is excited by input signal. This is also output signal. A sample of output signal is taken and fed back to the input to connect. If positive feedback, it is added. If positive feedback, it is added to the input plus feedback signal. Then the signal improved and amplified again. If the continuous feedback, continuously the signal improved and amplified again, then the continuous signal is available, this is oscillation. Otherwise, negative feedback, it is decreased by input signal, that is negative feedback amplifiers. Okay, negative feedback amplifier is discussed in later in the subject electronic circuit analysis. I will discuss later. Okay, so here okay, after rectifiers, the amplifiers are developed to voltage amplifiers, current amplifiers, power amplifiers, feedback amplifiers, like that. And then the one more BJT is PNP and NPN types of BJT are there. Okay, according to the application we can use. The both operations and properties are completely opposite. Okay, so here I am going to the next level of electronics, from amplifiers to MOSFETs. Field effect transistor. Field effect transistor is completely opposite to BJT. In BJT, there is only terminals and two junctions. It is a current control device, BJT. Only current components are available. We will discuss and analyze the BJT to generate the current components. Okay. So here field effect transistor, it is involved a field and a channel between the terminals. Now, what are the terminals and symbol? Let us discuss. Field effect transistor symbol, in which this is gate, terminal G, gate. This is one more terminal D, drain. One more terminal S, source. Okay, in which the basic concept is gate is the input terminal to apply the input voltage. This is voltage control device. The operation of the FET is controlled by the applied voltage to the gate with respect to source. It is termed as VGS. Whenever the gate voltage is applied, then the electrons are developed and generated in the path that is called channel. The path of electrons from drain to source. The path of electrons from drain to source is channel. There is a channel in FET. Okay. So here the electrons are developed and generated in a path from drain to source. So drain to source current flow is started when the gate voltage is enough. Gate voltage is applied and increased, then the electrons also increased. So IDS means IDS is developed. Flow of electrons is current. The current from drain to source is called IDS. IDS is developed in the channel. Okay. So wherever the current is flow, there is a voltage development also. That is the voltage developed from drain to source is called VDS. IDS, VDS, according to application of the gate voltage VGS. Okay. So N-type channel, P-type channel. N channel FET, P channel FET. Okay. These are the basics. So the substrate is different. You have to take a substrate and diffusions. This is another concept. So the FET is one of the device in electronics. Okay. Next, we are discussed about the basics and development of the circuits, basic circuits, linear analog circuits. Those are the rectifiers, amplifiers, field effect transistor, like that. So next, the electronic, before going to the electronic circuit analysis. So suppose we take an amplifier. This is amplifier, input signal, output signal. Input signal is applied, it is a sinusoidal waveform, output is also a sinusoidal waveform. Input voltage Vi, output voltage V0. General amplifier circuit. The signal contains amplitude, peak to peak amplitude, that is the measurement of voltage. Number of cycles per second, that is the frequency of the signal. And waveform has time period, time, and the signal has the phase angle like this. This is 90 degrees, this is 180 degrees, like that. The phase angle, the full cycle is the 360 degrees. At 0 degrees, again start the another cycle. Okay. So here the properties we have to measure to the input signal as well as to the output signal. According to the frequency, the characteristics of output are changed. according to the input frequency. Input frequency is changed, the output voltage will be changed. Input frequency is changed, output voltage changed. The gain also changed. Here the important characteristic of the amplifier to measure is gain. Gain. It is the ratio of output voltage by input voltage. How much the amplifier gained? How much the amplifier gained? We can calculate using this formula. This is called gain. If it is the voltage amplifier, it is voltage gain. Gain means how much the amplifier is amplified. How much the amplifier is gained. So gain is also called as amplification factor. Amplification factor A. V0 by Vi. Amplification factor A. If it is the voltage gain, voltage amplifier V0 by Vi. So it is denoted as AV in suffix V. V means voltage amplifier. Current amplifier means current is denoted by I. Okay, AI. I0 by II. Suppose it is current amplifier, AI equal to I0 by II. Okay, whenever the calculating voltage means V equal to IR, a basic formula. Okay, there is a current in a circuit. A current is passed from the resistance. There should be a voltage drop. Whenever the current is there, whenever the resistance is there, both are creating the voltage. V equal to IR. Okay, so these parameters available. So to analyze an amplifier, technically we have to analyze an amplifier and calculate the values for voltage, frequency, time period, voltage gain. Voltage gain is decibels also, we can calculate. Decibels means 20 log AV and Rastam. This is the formula. So 20 log AV means voltage gain in decibels, dB, gain in dB. Okay, this much of analysis is needed in the circuit of amplifier using the components. Okay, here two types of analysis, frequency amplifiers, two types of analysis in frequency amplifiers. Here frequency amplifiers means low frequency amplifiers. Low frequency amplifiers. Low frequency amplifiers. High frequency amplifiers. So basically two types of amplification. Low frequency means audio frequency amplifiers. Okay. The high frequency means radio frequency amplifiers. Okay. Low frequency analysis of amplifiers. High frequency analysis of amplifiers. Normal amplifier circuits having the components, resistances and capacitances, transistors, and then impedance matching. If it is input impedance or output impedance, there should be impedance matching to the circuit. Okay, we have to calculate using some formulas, and each and every device, each and every circuit we have to calculate using the formulas. Okay, so low frequency amplifiers are amplifying the audio frequency signals. Low frequency amplifiers can analyzed by using some parameters, and another level of the amplifier circuit, basic amplifier circuit, is using the parameters. By using those parameters we can calculate and analyze, we can formulate different types of gain, input impedance, output admittance, different types of characteristics of an amplifier can be analyzed using some parameters. Those parameters are called H parameters. H parameters. H means hybrid parameters. Before going to the electronic circuit analysis, you have to know the basics of electronics and what are the low frequency amplifiers, what are the high frequency amplifiers. Okay, low frequency amplifiers means a low frequency amplification process. A small frequencies, small signal frequencies, small signal analysis. The name also small signal analysis. Low frequency amplifiers means small signal analysis. Okay, the small signal analysis we use H parameters because a normal amplifier circuit, suppose a transistor, a collector resistance, an emitter resistance, a DC blocking capacitor, and then a voltage source, input voltage source, and then plus VCC power supply, and a voltage divided biasing network, and output is taken using the coupling capacitance to the output. If there is a bypass capacitance V0, input voltage, output voltage. Using these devices, we can formulate the output voltage, input resistance, output resistance, we can formulate. But in low frequency analysis, this type of formulations, this type of analysis not possible. In order to measure gain, current, in order to measure input impedance, output admittance, in a normal amplification process is not enough. So we have to invent some parameters. Okay, you have to go explain for some parameters to analyze the low frequency analysis. Okay, so next class we have to analyze the low frequency analysis of amplifiers, in which today I have given the basics of electronics, how generated or developed the electronics from its material level to circuit level. Then different circuits, rectifiers, amplifiers, oscillators, and then in-depth concept is amplifiers, because in ECS subject amplifier analysis is most important. There are two types of analysis: low frequency analysis, high frequency analysis. In the normal analysis of the circuit, we can formulate using the V equal to IR formula and resistance formulas, we can analyze. But in the low frequency signals, we can analyze using parameters. The normal analysis is not enough to design a low frequency amplifiers to analyze. So these parameters are H parameters. H parameters to design low frequency analysis we can discuss in the next class. Okay, so today you have to remember that low frequency analysis is analyzed by using H parameters. This is the key point today. Low frequency amplifiers are analyzed by using H parameters. We can discuss about H parameters and analysis of the low frequency amplifiers in the next class. Thank you.